The first function. So to begin, the area of the region enclosed. So what do I mean by area? So it's not blue on your paper, but it's blue on mine. So this is the function. So the function is the graph, right? So the function is the graph. So when I say area under the curve, it's the area from the blue down to the x-axis. Always goes back to the x-axis. So in other words, the area is this. Let me highlight it. Okay. All of this represents the area that we're finding. Okay. So it goes from the blue down to the x-axis. Okay. Well, if I was going to best find this area here, what would be the best way to find that area? What would be the best or the easiest way to find the area of the green? Count, right? Each box here is 1 by 1 unit, right? So you can count. You can count each box as a unit. That works. Or you can divide them. You can divide them up into rectangles or squares, right? Essentially, you're doing the same thing, but you're just finding area. Either one works. Whatever way you're going to do it. So this one would be a 2 by 2, so this is 4. The next one is a 2 by 3, so it's a 6. 2 by 1 is a 2. And the last one's a 2 by 5, so it's 10. Add them all up, you get 22.
Oh, wait, that was actually, whoa.
Okay.
I thought we were actually doing a different method.
All right.
You're correct.
So the next one, what would the next one be? So do the next one. The next one is, area is a little different, but you can essentially use the same procedure, the same strategy that you did the last time, right? Count boxes, or you can divvy them up into rectangles. Two by 4 is 8. 3. 1, 2, 3. 12. So what do we get? 13 plus 3 is 16. 28.
What? Is it 2 by 3, 16, 20, 19, 20, 26? It's a 2 by 3.
It's a 2 by, yes, you're right. Yeah, it's a 2 by 3, yep. This one's a 2 by 3. So 26.
Is that like a force?
Okay. So we would say area under the curve for the first function is 22. Area under the curve for the second function is 26. The bounds, another word you're going to start to hear, the bounds of the first one. So when we talk about bounds, we only talk about x's. Right now we're just talking about x's. So 0 to 8, right? So the bounds are from 0 to 8. The bounds are from 0 to 8, right? Okay. All right, so now, but we know that functions have curves to them, right? So they have curves to them. So what I want you to do right now is use the same method you did to approximate. Approximate for both of these guys. Because you're not going to get exact because they're curved, right? The two functions are curves. But use the same method you just did to approximate what it's going to be. Approximate means come close to it. So the method you use is going to be different slightly, like I said. Okay? Some of your boxes are going to be too big. Some of them are going to be too small. You kind of try to fill in where you can.
I thought it was if it's more than half.
Okay? So the first guy, I'm a little bit more for some of them. So this one there. And then I go a little bit above because I need to make up from what I didn't do, from what the missing underneath.
Maybe it's because he missed those.
So then here, so there's a lot of empties that I'm missing, so I go a little bit above. Right? It's an approximation. It's not exact, it's an approximation. That's what we're doing today. Today is an approximation. We're not going to be exact. Okay? So 2 times 1 is 2. 2 times 1, or 3 times 1 is 3. That's a 2 by 3, 6. 1, 1. 2 by 6 is 12. So my approximation is 11, 12, 13, 25. That's my approximation. Is yours going to be 25? No, you could be 24, 26, 27, 23, somewhere around there. Your approximation, right? It's an approximation. You're just coming as close as you can to the answer. Okay? So do the next one. Now do the next one if you haven't already. We'll see how close we can come to everybody getting the same one.
Now I think it says it's not. This is what I would go with.
11 plus 3, 14, 26. So for the second one, I came up 26. That's my approximation. Okay?
She took so much.
So when we approximate, so at the beginning of the top of the page, it says estimating with finite sums. Estimation is approximating. So this method is an approximate. It's not going to give you an exact answer. Finite means actual numbers, so not decimals, right? Riemann sums. Riemann was the guy who developed this method. Sums are because we are adding. What are we adding? We're adding blocks. We're adding sections. It's accumulation. We're accumulating area. We get bigger as we go. Okay?
Did you go 1, 2, 3, 1, 2, 3, 4, 5, 6?
Okay? So that's where that comes from. Riemann sums means a rectangular approximation. Okay? That's what this says right here. Okay. There are 3 types of rectangular approximations. There's three different ways to use rectangles to approximate. They all, the first way is left rectangular approximation. It's called LRAM, left rectangular approximation method. The next one is right rectangular approximation method, and then the last one is middle rectangular approximation method. Okay, they're all very similar except for their endpoints. You see that the word endpoint is, or midpoint, right? So the way to tell is which part of the rectangle is touching the blue. Which part of the rectangle is touching the blue? Well, let's see. Touching the blue right there, right? Touching the blue, touching the blue, touching the blue. What side is that of the rectangle? Is that the left side? Is that the right side? Or is it the middle? The left side, right? Left, 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 left. So this is an example of LRAM, right? LRAM, left rectangular approximation method. Okay. The next one, which part of the blue is touching the rectangles? The left, the right, or the middle? Middle, right? Middle, 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 middle. MRAM.
No justice for RAM. No justice
Okay.
for RAM.
All right. Okay. The total area under the curve is then approximately equal to the total area of the rectangles. It means to find it, you're just finding area. To use each of these methods, you're just finding area of each of the rectangles, adding them up, like we've been doing. Okay. Which of these two gives a better approximation? So which of these two would have a better, would be closest to the actual answer? Would it be LRAM or MRAM? MRAM, I think, right? MRAM has less missing, right? This guy has like a whole section here, and then it goes over a little bit, then it goes here, and then here, right? The missing parts, it goes over a little bit there, but those kind of balance each other out. So I'd say MRAM's a little bit closer. That's what's you're most likely, MRAM will be the closest to actually finding the answer, okay? All right, so now we're gonna do examples of RRAM and LRAM, okay? We're gonna draw the rectangles and then we're gonna find the area of them, okay? So RRAM will be the first one. They're the same function. Both of them are the same function. So let's do RRAM first. RRAM means the top right corner is going to touch the function. Okay? And those dots are already made for you. So those dots are where that's going to represent the height of the rectangle. Okay? So the first rectangle is going to look like this. It's going to go up to the first dot. And then it's going to go back to over. Up and then over. That's the first rectangle. The second rectangle, the next dot is at 4. How high are we going to go for at 4? How high? What is the y value going to be at 4?
3.
3, right? And then you're going to go straight over and meet the other dot. The next rectangle is going to be not as wide, right? It's only so at 5. So you see the next dot is at 5. So we're just going to go up 1, and we're going to go left as far as we can. That makes a square or a rectangle. The next dot is at 6, so we got to go, when x is 6, we got to go up to 5, and then we're only going to go over 1 unit because otherwise it wouldn't be a rectangle if I went too far to the left. And then the last dot is at 8, so I'm also going to go up to that dot, which is at 5, and then go over. Okay. That's an example of LRAM, or RRAM, sorry, RRAM. Right, that means the top right is going to touch. So everywhere has a top right of the rectangle touching. Okay. So the first one is a 2 by 3, which is a 6. Also a 2 by 3, a 1 by 1, a 1 by 5, and a 2 by 5. So what is that? 6, 12, 13, 18, 28? 28 units. Okay. So now we're going to do, on the right, we're going to do the same thing, but now we're going to use LRAM. So it's going to kind of be like one of the ones we just saw. So now each of those dots is going to touch the left corner, the left corner. So how tall and how wide is the first rectangle going to be?
2 by 2.
It's going to be a 2 by 2, yeah. Because the top, we're not going this way. I'm not going this way and then coming back over. That's an RRAM. I need the left side. So the left side starts over here and it goes up to 2, and that's where it's going to touch. And it goes over to 2 because that's where the next dot is. So now I got to touch the next dot. So I'm going to start at 2 and go up until I touch the next dot. The left corner touches it, and I go up to the next dot. Okay, up to 4, I'm going to go up to 3, and then I'm only going to go over 1. Each of those green dots tells me how high the rectangle is going to go. This one's going to be really short. This one's going to be tall, and it's going to go to the next one. And this is LRAM. So LRAM is 4, 2 by 2 is 4, 2 by 3 is 6, 1 by 3 is 3, this is 1, and then 2 by 5 is 10. So that's 24. Same function, right? Same function, different areas, because they're approximations. Okay. So if you're not quite sure, that doesn't click. Sometimes it takes a few examples. We're going to do some more examples on the other side. They give us 3 functions. It's actually the same function, but they want us to do LRAM, RRAM, MRAM. Okay?
Where are my dots? I need to choose.
All right. So sometimes they don't have dots in betweens. This one only has the beginning dot and the end dot, right? Because it goes from 1 to 3. How many, so this is a great question. How many rectangles, because they don't tell me how many rectangles, but they give me hints. Actually, no, they tell me how many rectangles. How many rectangles do we need? This one they do. 4 rectangles, right? How wide is each rectangle going to be? Half a unit. Half a unit. How did we know it's going to be half a unit? How wide is the whole thing? 2 units, right? 1 to 3. 2 divided by 4 is 1/2, right? Because you need 4 rectangles. If I just have 2 rectangles, they would each be 1 unit. But I need more than 2. I need double that. So that means they need to be half a unit wide. Okay? You take the number of rectangles and divide it by how wide, or the other opposite. How wide on top divided by rectangles on the bottom. Okay? So, first one is going to be LRAM. So let's go LRAM. Okay? That means top left is going to touch. So we're going to start at 1, so we only go from 1 to 3. So we're going to go up until we hit the function, and then we're going to go over half, right? Because we need to go half. So I'm going to go up until I hit the function, and then I'm going to go over to 1.5, and then go straight down. Pick up at 1.5. So I'm going to pick up at 1.5. I need to go up until I hit the function. So I'm going to hit the function right there, and then I'm going to go over to 2 and go straight down. Okay. I left off at 2. I'm going to go up until I hit the function, and then go horizontally across till I get to 2.5. So I'm going to go there, over 1/2, come straight down. And one more time. I'm at 2.5. I'm going to go up till I hit the graph, go over, and I should finish at 3. And I should have my 4 rectangles. 1, 2, 3, 4 dots, all touching the top left. Okay? We're going to come back to this one because we're actually going to figure out what the area is of each of those bars. But let's go to RRAM first. Let's draw the pictures first. Sometimes that's the hardest part, drawing the pictures. Okay. All right. So same thing. Each rectangle is going to be 0.5 width. Except this time, I'm not going to start with the left side. I'm going to start with the right side. So I'm actually going to start at 1.5 and go up. I'm going to start at 1.5 and go straight up until I hit the function. Right there. Come over left, go down. Okay, I left off at 2. So now 2, I'm going to go up, hit the function, turn left. Go down. Okay, so next I'm going to go to 2.5, go as far as I can up, and turn left. Last one is 3. 3, I'm going to go all the way up. That dot's already made for me, so I can go there, go left, and there you go. The graph hits each rectangle at the top right corner. RRAM. The last one is MRAM. MRAM. Okay? MRAM. Midpoint. So it's going to hit the graph, the parabola is going to hit the rectangle right dead center in the middle. Okay? So we still need 4 rectangles, just like that. Okay. Now, the thing is here, the left side and the right side is not going to dictate how tall it goes. The middle is going to dictate. So let's start with the first one. I got 1 to 1.5. 1, I'm not going to go up from 1, otherwise that'd be a left. I'm not going to go up from 1.5, because that would be a right. I'm going to go in the middle. So right in the middle, and make a dot.
1.25.
1.25. So I'm going to go up, make a dot right there.
Slightly above left.
Yeah, just above 1. That's how tall my rectangle is going to be. The midpoint is determining how tall the rectangle is going to be. So then I'm going to go to 1.75, and I'm going to go up and make a dot. Go up and make a dot. Just above 1.5, up.
1.01.
Okay. Next rectangle is 2.25. 2.25. So that's going to go up and right about 2.5. I'm going to make a dot. That's going to determine how tall the next rectangle is going to be. And then the last one, 2.75. I'm going to go up until I hit the blue. Looks like right at 4. I'm going to hit the blue. That's how tall. That's where my dot's going to be. And I'm going to go up. That determines how tall each rectangle is. And there you got it. So now there we go. Okay, that's the difference. Okay, so we drew the picture. So the next thing is each of the boxes is to determine area of each rectangle. Area of each rectangle. Okay, so let's start with LRAM. How tall is the first rectangle? So each of them is going to be a half, right? 0.5? Yeah. So the first rectangle is 0.5 times how tall?
1.
Times 1 unit, right? Then I'm going to add that. The next rectangle is still 0.5.
Oh no, not times 1.
Looks like 1.25. plus, again, 0.5, because that's the same width. The widths are always the same. The next one looks like 2 units tall. And then the last one is, what is that, 3.25? Yeah, that's what I was going to say. Yeah, they each have a 0.5, 0.5, 0.5, 0.5. You can factor a 0.5 out and just add the numbers 1 plus 1.25 plus 2 plus 3.25 and then divide it by 2. You can do that, or you can multiply and add, whatever you want to do.
Multiply by 5.
Okay. Let's see. Okay, so 1.5, 1 divided by, or 1 times would be 0.5. Half of 1.25, I think, is 675, I think. Is that right?
It's like, I don't know what the big one is.
This one's just a 1.
No, it'd be 0.575, right?
575. No, 575.
Let's see. 575, 575. That was right before. 675.
Equals.
675.
I think it's 625.
625?
I think. Yeah, it is.
625? Okay, we'll go with it. If it's wrong, we know who to blame.
All right, quick.
0.5. All right, now what is 3.25 divided by 1.75? No, 1 point, I think it's 1.625. If that one's wrong, you blame me. All right, now we got to add them. 1.5 plus something. Let me use my notes from last year. I don't want to use a calculator, so I'll just use my notes from last year. Let's see here. 3.75. 3.75. Okay. Next one, RAM. Again, they're all 0.5 in width. The first one looks like 1.25. Yep, 1.25 height plus 0.5 in width. The next one is 2.2, no, just 2.
2.2.
The next one is 3.25. And then the last one is 5.
Oh, man. Yeah, I think this one's going to be pretty far out.
So we already did some of this math. So 0.625 plus 1 plus 1.625 plus 2.5. Add all of those up and you get 7.75. Or sorry, 5.75. 5.75. Okay. The last one's a little tricky because we're not using the left side, we're not using the right side, we're using the midpoint to determine the height, right? So the width is all going to be the same.
Oh, no.
Okay. So let's look at the first one. Let's go one by one. The width is 0.5. The height looks like it's just above 1. Looks like it's just above 1. Okay, I'm not going to make you do this, But let's say you had this problem on a test or a quiz, and I don't want to approximate my approximate, right? I don't want to, we're already approximating, right? This method is approximation. And I don't want to have to eyeball approximate the approximation, because that's when you go way off. So let's say I want to get an answer. How would I determine the height of that? What's the easiest way to determine the height of it? I don't want to say easy, but what's the best way?
Close enough to 1.
Well, then you're approximating the approximation. We don't want to approximate it. Let's say we want to get it exactly right. What's the best way to figure out the height?
No. The one above, I don't know.
In other words, how do I find where that dot, how tall is that dot? How do I figure that out? How do I figure out when x is 1.25, what y is going to be? When x is 1.2, there, use the function, right? Use the function. You'd plug in 1.25 for x, and then you would get y. That would tell you how tall y is. I'm not going to make you do that, but it could happen on a test or a quiz. So, well, there you go, right? So when you do that, you're going to get 1.0625.
Now have it.
If you would plug in so you would do f of 1.25. Like I said, I'm not going to do this for all of them, but I at least want to do it one time in your notes so that you know how we got that number. And I'm using 1.25 because it's the midpoint. So when I square 1.25 and then I double it and subtract it, you get 1.0625, and that's how I got the height. So to figure out the next height, what number would I plug in to the function? That's the first rectangle. How do I figure out the second rectangle? 1.75, good, 1.75. When you do that, your y value is going to be 1.5625. I'm not making you guys do the math because as long as you know how to do it, so if you were to do it, you could figure it out. The third rectangle is when x is 2.25, right? That one's going to be 2.5625.
Wait, 2.2? Okay.
So just over 2.2. And then the last one is 2.75. When I plug that in, I'm going to get just over 4. A lot of 625s.
I'll have all of these. Or I think the middle one might be the most accurate.
Good. And then when you add all those, multiply and add them, you're going to get 4.625.
Oh, what? No.
Okay.
No having them? What do I
Okay.
3.75, 5.75, 6.
All right, so look at them. Which one do you think is the most accurate to the actual answer?
Could be 4.
MRAM, right? Pretty obvious. MRAM's the closest. Okay, so here we go. Here's another question. Here's a bigger question. Which one is an overestimate? Which one is an underestimate? We know the best estimate, but which one is an overestimate means the number I found is too high. I know it's too high. And which one's too low? So yeah, LRAM is an underestimate, right? I never went above the blue, but there's some that's not taken, and then on the RRAM, there's some that I always overestimated, right? So here's what they're going to ask you. They're going to give you a function, and they're going to say, if you were to use LRAM or RRAM, would it be an overestimate or an underestimate? How would I figure that out? So if they were to give you a function and they said, I want you to use, so I'm not going to give you a function because that's not the point of it. I just want to figure out how I would do it. So if they were to give you a function, right, and you need to figure out, and then they also gave you, let's say, LRAM. Is it going to be an overestimate or an underestimate? How would I figure that out? Or the same thing for RRAM. Over or under? What's causing, in other words, for this one, let's look at the one we have. What's causing LRAM to be an underestimate? That one's the best, right? M is always going to be the best. But what's causing L to be an underestimate? Right? That'll work if the function is increasing, right? From 1 to 3, the function is increasing, right? It's going up. So if the function is increasing, LRAM is always going to be an underestimate. What if it was decreasing? What do you think LRAM would be? Overestimate. RRAM's the opposite. If the function is increasing, RRAM is always going to be an overestimate. But if the opposite was true, right? If my bounds were from, instead of 1 to 3, it was from -1 to 1, it's decreasing, right? It would be the opposite. Okay, it would be the opposite. All right? Yep. That's why I'm telling you guys. Okay? Because they will say that. They'll say, and then I'll have students like, what do you mean overestimate, underestimate? I'm like, well, what would the picture look like? What would the picture look like? Would it look like one of these? Would it look like a LRAM? LRAM's not always going to be an underestimate. It'll be an overestimate sometimes when the function is decreasing, right? So LRAM, write this down. LRAM will be an overestimate when the function is decreasing, but an underestimate when it's increasing. And then vice versa for here. Okay. MRAM is always going to be the best. For rectangular approximation method, MRAM's the best. It's the most pain in the butt because you got to figure out in between, and then that's usually a decimal and things like that, right? But it's the best. Okay. Let's see, what do we got? Okay, we're good at time. All right. Okay, so what if they give you a table? They ask you to do the same thing, but they give you a table instead of a picture. You can draw a picture. Pictures are okay. I can draw a graph. There's 8 dots there. I can make 8 dots. You don't have to do that with a table, but you can do that, right? So for the first one, let's make a little picture here. Let's make a little picture. I'll show you how to do it with a picture, and I'll show you how to do it without a picture, and then you can decide what you want. Okay? So we go from 0 to 8. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6. And then the y's go from 3, the lowest is 3, the highest is 21. So you can count by 5s. 5, 10, 15, 20, 25. This is probably the easiest way to do it, but it takes a little time. I'm going to show you the quicker way, but sometimes when I show you the quicker way, it doesn't make sense to some people, so I show that second. For some people, they're like, oh, I get it. Some people, they're like, they can't see it. It's hard to picture things. Math, the hardest part about math is being able to picture it in your head. So sometimes you don't want to do that. Okay? So we're doing a MRAM here, MRAM. Look at this guy here. Haven't seen with numbers there, right? What do you think 0 to 8 means? What do you think the 0 and the 8 mean? That's the x values. We go from 0, x is 0, to x is 8. Those are the bounds. They're called bounds. Okay? So those are the upper bounds and the lower bounds. And f of x is the table. Okay? All right, so let's make the first dot. The first dot is at 0, 21. 0, 21. The next dot is at 120. 215. Mm-hmm. It's decreasing. 314. 413. 512. 611. 75. 83. Yep. So yeah, it is decreasing the whole way through, right? It is decreasing the whole way through. So the function looks like that. Then you make rectangles. How many rectangles? Does it say how many rectangles I need? 4. 4 subintervals. That's what that means, rectangles. I need 4 rectangles for this guy. So how wide are each rectangle going to be if I need 4? 2, right? 4, 8. There's 8 wide, and I need 4 in between. So that's 8 divided by 4. 2.
Oh, we got the midpoint.
So the first one is going to go from 0 to 2, right? 0 to 2. The next one's going to go from 2 to 4. The next one's going to go from 4 to 6. And the last one's going to go from 6 to 8. Okay? So how tall is the first rectangle going to go? What's going to determine the height of the first rectangle?
The midpoint.
The midpoint from 0 to 2. What is the midpoint from 0 to 2? 1. So where is the dot for 1? 21. Or 20, sorry. That's the first rectangle. So it's 2 by 20. 2 by 20. The next one's going to go from 2 to 4. The midpoint's going to determine how tall. So 3, 14. The next one's going to go from 4 to 6. So 5 is going to determine the height. At 5, the height is 12. The last rectangle, it goes from 6 to 8. 7 is going to determine how tall. So 7 is going to be 5. There are the rectangles. Okay, so the first rectangle is 2 by 20, 40 width, or 40 area. 2 times 20. The second one is 15 times 2, 30. The next one is 12 times 2.
14 times 2.
14 times 2? Oh, okay. Yep.
2 to 4.
So it'll be 28. The last one is 2 by 5.
Big old time.
Add them all together, you get 102. So this is how we write it. We say the area from 0 to 8 for the function f of x dx equals 102. Because we found the area under the curve.
Okay.
To me, that's the easiest way to do it. Now, there is a quicker method. And I'll show you the quicker method. Okay, I'll show you the quicker method right now. The quicker method is don't draw a graph. Just look at the table. Okay? So I'm going to show you how to do it. So just watch me do it. Don't necessarily write this down. Watch me do it. Okay? I'm not going to look at the graph because I know the answer. How wide is this the interval go from? How wide? 0 to 8, right? So it's 8. How many subintervals, how many rectangles do I need? So how wide is each, or how wide is each of them going to be? 2, right? So I'm going to draw rectangles. The first one's going to go from 0 to 2. Well, they're not rectangles. They're more, yeah, they're not really rectangles. The next one goes from 2 to 4. The next one goes from, oh wait.
Let me guess, you just multiply 2 with the numbers in between.
The next one goes from 2 to 4. The next one goes, yeah, they're not really rectangles, they're more brackets, connectors, right?
Let me guess, you just go either.
And then what's going to determine the height of each? The middle. 1. So this is going to be a 2 by 20. 2 times 20. The next one is 2 by 14. The next one is 2 by 12. And the last one is 2 by 5. Multiply and add. You don't have to draw it. It took us a fraction of the time, right? If that makes sense to you, use it. If it doesn't make sense to you, draw a picture and just do the graph like you did. Okay? It just depends on what makes sense to you. Like I've shown that every year, and every year I have students that are like, it's not quite clicking that way. So draw a picture. We get the same answer. Okay? So I'm going to try that on my next problem. I'm not going to do a graph for the next one. I'm going to do exactly what I just did to show you. Okay? So this one goes from 2 to 12, and I need 3 subintervals. Each subinterval needs to be how wide? Ideally, it's 10 wide, right? If they needed to be equal, it would be like 3 point something, 3.33, right?
Yeah.
But they don't even give me enough data for that. So, and it doesn't say that the subintervals have to be equal. So these rectangles are going to be a little different. They're not going to be the same width. They're not all going to be the same width. Okay? So the first rectangle is going to go from 2 to 6. So it's going to be 4 wide, right? The next one's also going to be 4 wide. And the last one's going to be 2 wide. Since they want 3 rectangles, that's the best I could do. And it doesn't say the rectangles have to be the same width. Sometimes I'll do that.
I think I did it right.
Okay, so this one's an LRAM. Which y value is going to determine the height of the first rectangle?
The left.
The left. So the left side, right? The left side, the top of the left, right? So how tall? We know it's going to be 4 wide. How tall is that dot going to be? 21. 21. Plus. It's going to be 4 wide. How tall is that second dot going to be? 4. The last one is 2 width. How tall is that last one going to be? 3. So what is it? 84 plus 16 plus 6, which is 106. So in other words, the area from 2 to 12 for the function is 106. If that doesn't quite make sense to you, draw pictures. Draw the graph, make 4 dots. This graph wouldn't be as big. wouldn't be as much because it's just 4 dots instead of 8 dots. So if that doesn't make sense to you, do like we did on example number 5, okay? All right. That's where we're going to stop. We have 2 more problems, and then tomorrow we'll do some practice, okay? 2 more problems, same thing, but a little different.
Same, but different.
Same but different.